Good day. We'll discuss solving rational inequalities. When we say inequalities, it should use these four or either of these four symbols: greater than or equal, or less than. So we have this procedure in solving rational inequalities. So rewrite the inequality as a single fraction on one side of the inequality symbol and zero on the other side. So usually the rational expression is on the left side, so only one rational expression or fraction, then either of the four symbol, and then the other side must be zero. That is the first step. Number two, we must locate the x values for which the rational expression is zero. So a rational expression is zero, of course, if the numerator is zero. So that is why we will get the zeros of the numerator. And for the undefined zeros, it should be on the denominator, because if the denominator is zero, then of course the overall fraction is undefined, given that the numerator is also non-zero. And of course, the main strategy here is factoring. No? If the given expression is factorable, then you should factor. Then if not, then of course you may proceed in finding the zeros of the given expression. Then we will plot it on a number line, and then we will use this concept later to know whether to use bracket or parentheses. We use bracket if the endpoints are included. Say for example from A to B. So meaning A and B are included in the interval, in this interval. But when we say like this, parenthesis, meaning A is not included and B is also not included. But if we have this, A is included but A is not included but B is included. Okay, because of this bracket. Usually we use parenthesis if it's on the denominator, because we cannot include the zeros of the denominator, because it will make the fraction or rational expression undefined. And of course, if we use this strict notation, greater than and less than, meaning also the endpoints are not included, because it is strict that it should be greater than or less than. But in order for this to be, for us to understand, then we must apply this in a given problem later. And then we must select a test point. So it must be inside the interval, and we should summarize the intervals containing the solutions. So to understand these steps, let's have some examples. Okay, so given this example, inequality. So since the right side is not zero, we should transpose 1. Okay, so this will become -1. And then the other side is 0, but this side is not yet a single fraction, so we must write this in a single fraction. So the LCD here is just x plus 1. Okay, you might cross multiply, you may do so. Okay, so 2x times 1 minus 1 times x plus 1. But the main thing here is do not eliminate the denominator or the LCD. You can cross multiply, or you can apply the rational equation strategy that we must distribute our LCD. So x plus 1 times 2x over x plus 1 minus, we have x plus 1, your LCD, times this one. So we have cancel. So we have 2x, and we have this minus x plus 1. So this is now your numerator here. 2x minus the quantity x plus 1. Okay. Next is we should remove the grouping symbol. So we have negative x and negative 1. Then combine 2x minus x. If is x, then copy minus 1. So this is now our step 1. X minus 1 over x plus 1 is greater than or equal to 0. This is a single rational expression. And the other side is 0. So let's go now to step 2. For step 2, we must find the zeros of the numerator and the denominator. Our numerator is x minus 1. So transpose 1, we have x equals 1. For the denominator, we have x plus 1. So transpose 1, so we have negative 1. So our numerator is x plus 1. Our denominator is x equals negative 1. So for the next step, we should plot these points on the number line given. Again, x equals 1 for the numerator, negative 1 for the denominator. Okay, take note that on the number line, this is negative infinity and this is positive infinity. So let's first plot these points. 1 is here. Let's arrange them. Negative 1 is, of course, on the left side. Do not include any other number. Okay, only the numbers here from step 2. Now, it is said here on the table that if it's greater than or equal or less than or equal, we should use bracket for the numerator and parentheses for the denominator. And if we use these symbols, all of them use parentheses. Now take note, in this example, we're using greater than or equal. So it's here. So meaning the numerator should be bracket. So numerator is 1, so we must use bracket for our intervals. And then for the denominator, which is negative 1, we should use parentheses. Okay, parentheses. So this will be our intervals now. So we have from negative infinity to negative 1. So we have this negative infinity to negative 1, parentheses, parentheses. The other one here at the middle is parentheses negative 1 to 1 bracket, meaning included C1. And then last is bracket 1 to positive infinity. Okay, so we will plot this now on the table. Okay. Now, these are the intervals from step 3. So from step 4, this is now step 4. So test points. Test points are values inside a given interval. So say for example, negative infinity to negative 1. Give a number, only one number from this interval. Of course, we should choose those numbers which can be manipulated or computed easily. So here, negative 2 is inside this interval. 0 is inside this interval, and 2 is inside this interval. Okay. Next, we should write the numerator. This is the numerator, and this is the denominator. Okay, all we need to do is to substitute these test points to our x. Okay, so this row here should be x minus 1, and the second row is x plus 2. So our x first on the first column is negative 2, so we have negative 2 minus 1 equals negative 3. 0 minus 1 is negative 1. 2 minus 1 is 1. So basically in the solution, you can write this on your scratch and we'll be needing only the signs. This one only, the signs. Okay. So take note, this is negative 3. So the sign is negative. So that is why I just put here the negative sign. Okay, on this one, 0 minus 1 is negative 1. So this is negative. So I put negative. This is positive 1. So I put positive. Okay, on the second row, we have negative 1 plus 1. Negative 2 plus 1, we have negative 1. So negative. 0 plus 1 was 1, so positive. 2 plus 1 is 3, so positive. By the way, in choosing your test points, please do not use these endpoints, no? To avoid the value of 0 Remember, 0 is non-negative and also non-positive. It has no sign. No, to avoid zeros here. Okay. So we have this. These are the values now. So let's proceed. So at the last, so this is our, at the end of step 1. No, this is the end of step 1. So it should be numerator divided by the denominator. So negative divided by negative is positive. Negative divided by positive, negative. Positive divided by positive is positive. Okay, so the basis for our answers now will be this last row. Now, since the inequality in step 1 uses this, no, greater than or equal to 0, so facing the arrow faces the positive direction, so we choose the positive sign or symbol. Okay, so we will choose plus, plus, or positive. So therefore, our solution are this interval. So negative infinity to negative 1, union, bracket of 1 to positive infinity. Okay, if there are more than 2 intervals, you must use union. Okay, so these are the steps of or in finding or solving rational inequalities. Of course, if you already practice a lot of problems, this will be easy for you. Okay, for the next set of problems, I will only write the symbols. Okay, I will no longer write this one. Okay, you might you must practice solving small numbers on your head or brain or mind. Okay, now let's go to example number 2. Now, in this example, uh, step 1 is already satisfied because this is already a single rational expression, and then the other side it's already 0. So we'll proceed directly to step 2, which is finding the zeros of the numerator and the denominator. So our numerator is x plus 2, so the 0 is x equals negative 2. Okay, and the denominator is x minus 3, so we have x equals 3. Step 3 is to plot this on the number line. Okay, number line, so we have negative infinity, positive infinity, and then negative 2, and then 3. Now, negative 2 is on the numerator, and we're using less than or equal. So again, it's here, so we must use bracket for the numerator. Numerator is negative 2, so the bracket must be here for the interval, and then parenthesis must be here. Okay, so therefore we have these 3 intervals, negative infinity to negative 2, bracket. Then we have bracket negative 2 to 3, braces, parenthesis, then parenthesis, 3 to positive infinity. Okay, and you should put this on on the table for you. Okay, and test point. So I can have negative 3, can choose 0, and I can choose 4. So you can substitute these values on your mind. So negative 3. This is our numerator, x plus 2, and our denominator is x minus 3. So negative 3 plus 2, negative 1. So we have here negative. 0 plus 2 is positive 2, so positive. 4 plus 2 is 6, so positive. Next, on this denominator, negative 3 minus 3 is negative 6. So negative. 0 minus 3 is negative 3. So negative. 4 minus 3 is positive 1. So positive. Okay, so we have now on the last row, we have negative divided by negative is positive. Positive divided by negative is negative. Positive divided by positive is positive. Okay, now since the inequality in step 1 is less than or equal to 0, so facing to the negative side to the left side of the number line. So we must choose the negative symbol. So therefore, the solution is negative 2 to 3. So this symbol. So it should be bracket on negative 2 and parenthesis on the 3. Okay, next example. 2x minus 5 over x minus 5 is greater than 3. So step 1 is not yet satisfied. So we'll make this a single fraction and 0 on the other side. So transpose 3. So it will become negative 3. Okay, and you can cross multiply. Okay, 2x minus 5 times 1 minus 3 times x minus 5. Or again, you may use our strategy in the rational equation. The LCD is x minus 5 times 2x minus 5 over x minus 5 minus x minus 5 times 3. So cancel. So we have 2x minus 5. And on this side, of course, I will just write 3 times x minus 5. Okay, I'll just rearrange them. I just rearrange these two. So that is why this is now our numerator. So again, you can do this or you can do cross multiplication since the denominators are distinct. Iba-iba yung denominator. So this is now our rational expression here. So do not delete or erase or cancel the denominator on this side. So distribute 3. So we have 3x plus 15 since this is negative times negative, so positive. And then combine like terms. 2x minus 3x is negative x. Negative 5 plus 15 is positive 10. And just copy the denominator. So take note, our symbol here is greater than. So we're done with step 1. Now let's go to step 2. Finding the zero. So numerator, I can transpose negative x on the other side. So we have 10 is equal to x. Denominator, so we have x equals 5. So again, now we will plot these points, the numerator and the denominator. Now, our symbol is greater than, so it should be here. So it means we will be using parenthesis, no? Parenthesis lahat for our intervals. So negative infinity, positive infinity. Okay, so this is now 5 and this is 10. So parenthesis lahat. So our intervals are negative infinity to 5, parenthesis, 5 to 10, and then 10 to positive infinity. Okay, you write this on the table. Test points, I can have 0, I can have 6, and I can have 11. So 0 plus 10 is 10, so positive. Negative 6 plus 10 is 4, so positive. Negative 11 plus 10 is 1, so negative 1, so negative. Because negative 11 plus 1. Next, 0 minus 5 is negative 5. That is why it's negative. 6 minus 5 is 1, so positive. 11 minus 5 is 6, so positive. Okay, and then numerator divided by the denominator. So positive divided by negative, negative. Positive divided by positive, positive. Negative divided by positive, negative. Since the inequality in step 1 is greater than 0, so pointing to the positive direction, so we must choose the positive symbol. So therefore, this is now our solution, the interval from 5 to 10 exclusive. So meaning hindi kasali si 5 and 10. Okay. Next example. So again, hindi satisfied ang step 1. So transpose 1x, 1 over x. So magiging negative 1 over x. And then the denominators are distinct, so you can cross multiply. Or again, you can try the LCD. So our LCD here is x times x minus 2. So times 3 over x minus 2 minus x times x minus 2 times 1 over x. Diba? Cancel x minus 2. So we have 3x or x times 3 minus cancel si x. So we have this is x minus 2 then parenthesis. So ganito dapat sa itaas. So we have this 3x minus 1 times x minus 2. Of course, the LCD is still x times x minus 2. Okay, then distribute the numerator. So we have negative x and positive 2. Then we have now 3x minus x is 2x, and then copy plus 2. So this can be our step number 1, a single fraction and 0 on the other side. So take note, we're using now the symbol less than. So the next step is to find the zeros of the numerator and denominator. So transpose negative 2, divide both sides by 2. So x equals negative 1. And the other side, we have the denominator x times x minus 2. So either of these two is 0. So it's either x is 0 or x minus 2 is 0. So we have two factors. So solving for this one, we have 2. So therefore now in this particular problem, we have 3 values of x. No, we can have more than 2. You can have 3, 4, and so on, as long as you follow the process. Okay, and next we will post or plot this one in on a number line. So our numerator is negative 1. So this is negative infinity. So negative 1. We have the 0 and we have the 2. And this is the positive infinity. Now take note, we're using the less than. So it should be here. So parenthesis lahat. So our interval therefore are negative 1. Negative infinity to negative 1. Next is negative 1 to 0. Then 0 to 2. And 2 to positive infinity. Okay, these are the 4 intervals. So we have here test points. So I can have negative 2 here. Okay, you have no choice. You can have, this should be negative 0.5. Okay, negative 0.5. And this is, I can have 1. And I can have 3. Okay, so it should be negative 0.5 because 0.5 is here. No? So it should be negative 0.5 here. Okay, substitute. So substitute, if you substitute your negative 2 here, 2 times negative 2 is negative 4. Negative 4 plus 2 is negative 2. So this is negative. Negative 0.5 times 2x, so I times 2, so that is negative 1 plus 2, positive 1. 2 times 1 is 2 plus 2 is 4, so positive. 2 times 3 is 6 plus 2, 8, so positive. Now on this one, so we have negative 2. So we have negative 2. Negative 2 for this x. Now for this x minus 2. So negative 2 minus 2 is negative 4. Okay, for this part. So we have negative 2 times negative 4. We have positive 8. So that is why this is positive. Now for negative 0.5. So negative 0.5. Now negative 0.5 minus negative 2 is negative 2.5 because both of them are negative. So again, negative times negative is positive. Okay. Next, 1. So we have 1 times 1 minus 2 is negative 1. So positive times negative is negative. Next, we have 3 times 3 minus 2. is 1. So positive times positive is positive. Okay, so the signs now are complete. So let's have the bottom. So negative divided by positive is negative. Positive divided by positive is positive. Positive divided by negative is negative. Positive divided by positive is positive. And our symbol or inequality is less than or equal less than 0. So we must choose the negative symbol. So our intervals are negative infinity to negative 1 because this is minus, and union 0, 2. Okay. So next example, example 5. So only one expression and then the other side is 0. So step 1 is already satisfied. So let's proceed to step number 2. So we have x minus 2. So we have here x equals 2. On the denominator, take note that the factors of x squared minus 3x minus 10 are x minus 5 and x plus 2. So therefore, we have two values here. X minus 5 is equal to 0 and x plus 2 is equal to 0. So we have x equals 5 and x equals negative 2. So similar to the previous problem, we have three values of x. So post or plot this. So we have negative infinity, we have negative 2, we have 2, we have 5, and positive infinity. By the way, our symbol is greater than or equal. Okay, so our symbol is greater than or equal, so meaning the numerator must be bracket. So numerator is positive 2, so the brackets must be here. And the others are on the denominator, so parentheses. So we have now intervals, negative infinity to negative 2, parentheses, negative 2 to 2, bracket, then bracket 2 to 5, and then parentheses 5 to positive infinity. Okay, so put this on the table, and then our test points are negative 3, 0, 3, and 6. So substitute our x here, so we have negative 3 minus 2 is negative 5, so negative 0 minus 2 is negative 2, so negative 3 minus 2 is positive 1. 6 minus 2 is positive 4. Okay. Now on this part, you can have negative 5. So negative 3 minus 5 is negative 8 times negative 3 plus 2. So this is negative 8 and this is negative 1. Negative 8 times negative 1 is positive. Okay. Next, 0 minus 5, of course, is negative 5. So this is 0, this is 0. So we have negative times positive is negative. Okay, so this is negative. Next, we have 3 minus 5. This is negative 2. And we have 3 plus 2 is 5. So negative times positive is negative. And then last, 6 minus 5. 6 minus 5 is positive 1. 6 plus 2 is 8. So positive times positive is positive. So last, we have negative divided by positive is negative. Negative divided by negative is positive. Positive divided by negative is negative. Positive divided by positive is positive. So since our inequality is greater than or equal to 0, so we must choose the positive symbol. So therefore, these are our interval from negative 2 to 2, union 5 to positive infinity. So if you notice, the process are the same. So you must familiarize the process, not the problem. Okay, example 6. So not one rational expression and 0, so we can proceed to step number 2. So the numerator has factors x minus 4 and x plus 1, so we have two values. Okay, and denominator, this is a perfect trinomial square, so we have x minus 4. So it's okay to write only, to solve only for 1 because they are the same. So x minus 4 equals 0. So x equals 4. So if you notice, they are the same. No, so we can only plot one of them. So we will only plot negative 1 and 4. So because they are the same, I can only plot one of them. So we have negative infinity, negative 1, and 4. Then we have positive infinity. By the way, our symbol here is less than 0. So less than. So here, so we must use parentheses. So parentheses, parentheses, parentheses. So we have negative infinity to negative 1, negative 1 to 4, and 4 to positive infinity. So these are our intervals. So here. So test points, we can have negative 2, 0, and 5. Okay, so these are our numerator and denominator. So substituting these test points, we have these signs. Okay. So positive divided by positive is positive. Negative divided by positive is negative. Positive divided by positive is positive. So since the inequality is less than 0, so again we'll choose the minus sign. So therefore, our solution is this interval. Okay, last example, we have this. So we must rewrite this one in a single fraction and 0 on the other side. So step 1. So negative x will become positive x and 5 will become negative 5. And we can treat this as a single uh, component. So you can have this if you cross multiply. So only the LCD here is x, only x. Okay, so you can apply that one, or you can apply this 3x minus 15 over x. So if you notice, we can cancel x. That is why we have 3x minus 15 only. Then we have minus x times the x minus 5. That's why we have the. So this is our numerator. And again, do not delete or eliminate the LCD, which is x. Then distribute your x. So we have x squared minus 5x. And then I will arrange x squared first, then minus 2x since we have negative 5x plus 3x. So negative 2x, and we still have negative 15. So step 1 is already done. So let's go to step 2. So x squared minus 2x minus 15 has factors x minus 5 and x plus 3. So we have two values for our numerator. We have x equals 5 and x equals negative 3. Denominator, so our denominator is already x, is only x, so x equals 0. So no more transposition. So we have three values. Okay, by the way, our symbol is less than or equal. So less than or equal, so it should be bracket sa numerator. So negative infinity, negative 3, 0, and 5. Then we have the positive infinity. So our bracket is on the numerator, so this is bracket negative 3 and 5, and then parenthesis on 0. So you have now negative infinity to negative 3, negative 3 to 0, 0 to 5, and 5 to positive infinity. So write them here. So test points, we can have negative 4, negative 2, 1, and 6. Okay, if you substitute the values, then we have these signs. So we have these signs. So positive divided by negative is negative. Negative divided by negative is positive. Negative divided by positive is negative. Positive divided by positive is positive. So since we have this So less than or equal to 0, so facing the negative numbers, so we will choose the negative side. Okay, so therefore our intervals are the union of these two. By the way, this is example 7. Okay, so you may try this, practice. Okay, so practice this. So these are the answers. So thank you for listening.